Hey guys, welcome to today's MCAT question of the day. As always, we'll be working our way through one of the mini MCAT practice problems found at MCATselfprep.com, the home of the free MCAT prep course. I'm Andrew George, a 99th percentile MCAT tutor, and I'll be walking you through today's practice problem as if you're one of my private tutoring students. Be sure to hit pause and try this practice problem for yourself before watching my explanation. Before we jump into the calculations, let's talk about the purpose of a titration. The purpose of a titration is to calculate the unknown molarity of this solution in the flask. Okay, and we do this using the information we do know about the volume of that solution as well as the information we have about the burette. And because we have more information about the solution in the burette, we always start doing our calculations using the information about the solution in the burette, okay? And we're told that there are 46.3 milliliters of NaOH in that burette, and we're also told that the molarity of that solution is 0.287. Now, molarity is also known as moles per liter, so I need to convert these milliliters into moles per liter. So I'll do that by doing 1,000 milliliters per liter, right? And then one final conversion, I'm just going to use the molarity of 1 liter per 0.287 moles of NaOH to convert it into moles of NaOH, right? Now, as we've talked about in previous videos, these numbers are a nightmare to work with, right? It would be very hard to do this calculation quickly using these kind of numbers, right? And so what I'm going to do is I'm going to make them into easier numbers. And I walk you through all the details of dimensional analysis, approximations, scientific notation, all of these key math concepts that you need to do these kind of calculations quickly in my high-speed math mastery course. I highly recommend checking it out. So in this case, I think I'll convert this number to 5 times 10 to the first, and I'll convert this number to 1 times 10 to the third, and I'll convert this number to 3 times 10 to the negative 1, okay? So now I do this calculation, and I get, overall, I get 15 times 10 to the negative 3. So 15 times 10 to the negative third is the moles of NaOH, right? But I need to know the moles of HCl, right? So how am I going to figure out the moles of HCl based on the moles of NaOH? Well, the wonderful thing is that at the equivalence point, the moles of the acid are equal to the moles of the base, okay? That is such a key concept to memorize, is that at an equivalence point, moles are equal, okay? So I can say that these moles, 15 times 10 to the negative third moles of NaOH, is also moles of HCl, okay? So now I just need to divide this by the volume of HCl to get the molarity of the solution. And I'm told that there are 453 milliliters of HCl, which I'm just going to write as 0.5 liters, also known as 5 times 10 to the negative 1 liters, which, if you calculate all of this out, you're going to get 3 times 10 to the negative 2. And if we take a second look at our answer choices, it looks like answer choice D is going to be the closest to 3 times 10 to the negative 2. If you liked this MCAT question of the day, be sure to give it a like. And for more MCAT questions of the day, be sure to subscribe to this YouTube channel and enroll in our free MCAT prep course found at MCATselfprep.com. And if you are really looking to maximize your MCAT score, feel free to visit my tutoring profile page and request a free 10-minute phone consultation. I'd love to chat with you about your situation and how you can maximize your MCAT score. I look forward to hearing from you soon, and we'll see you next time.